Good morning, boys and girls. We are on page 94, and the number 2 says, use the trapezoids you drew to complete the task below. So I would look at my images in the first page, and I would answer the questions. So for A, it asks you to measure the angles of the trapezoid with your projector and record the measurements on the figures. For problem B, use a marker or crayon to circle pairs of angles inside each trapezoid with a sum equal to 180 degrees. Use a different color for each pair. So I already did that with you guys on page 93 earlier, so you don't have to do A or B. For number 3, list the properties that are shared by all the trapezoids that you worked with today. So one of the properties is that they have 4 straight sides, but they don't look all the same. So if you notice the trapezoids that I showed, they all have different, they all have 4 sides. 1, 2, 3, 4, 1, 2, 3, 4, but they all look different. And that's okay. They would still be considered a trapezoid. Number 2, they are quadrilaterals. Quadrilaterals all have 4 sides, right? 3, they have at least one pair of sides that are parallel. So if you notice, they have parallel lines. You have 2 right here. Those are parallel lines. And then you have another pair over here. Those are parallel lines. And you also have parallel lines right here. Oh, not that one, this one. So these are all considered parallel lines. And then you have parallel lines right here as well. The little arrows demonstrate that they are parallel. Okay? So question 4 asks, when can a quadrilateral also be called a trapezoid? So they can be called a trapezoid, but there is a rule to that. A quadrilateral can also be called a trapezoid when it has at least one pair of opposite parallel sides. So just like how you guys see it here, these all have parallel sides. That's exactly what I'm trying to say. Okay? For number 5, follow directions to draw one last trapezoid. Draw a segment AB parallel to the bottom of this page that is 5 centimeters long. So this is approximately 5 centimeters long. And a segment means that I'm drawing a line across. So I'm going to draw my line across. There you go. So it is parallel and it is about 5 centimeters long. I'm showing you guys that it is parallel. Now for the second one, I should have labeled that in red actually because that's the first step I did. I want to make sure you guys can kind of see how I did that. So I'm going to show that in red so that you know that it corresponds with problem A. Okay? So that's what I did for A. Draw a segment AB parallel to the bottom of this page that's 5 centimeters long. So it is parallel, and this is A, and this is B. Number B, draw two 55-degree angles with vertices at A and B so that an isosceles triangle is formed with AB as the base of the triangle. So I'm going to draw 2 vertices. These are called vertices. They are places where sides meet or angles meet. So that is my 55 degrees. And where does 55 degrees come from? 55 degrees. So an example I'm going to show you. This is 90 degrees. If I use a protractor and I measure my angle, this is 90 degrees. So imagine about half of 90, which is close to kind of 55 degrees, right? And that's why my angle looks like that. That is about 55 degrees. So I did B, and now I'm going to do problem C. which asks me to label the top vertex of your triangle as C. So now I'm going to label the top vertex, which is the very top, as C. For problem D, it asks you use your set square to draw a line parallel to AB that intersects both AC and BC. So now I drew a line that both intersects AC and BC. So AC and BC. So those are the lines that they're talking about. I'm going to label that in orange so that you guys can see what they were talking about. They wanted you to grade that triangle. Okay, so that's D. And then E, shade the trapezoid that you drew. So they want me to shade the trapezoid. Now, I'm going to use a different color. Okay, so they're not asking for the triangle. They're asking for the trapezoid. Okay, so this is the trapezoid, and that's what I'm shading in. And that's all you're doing for page 94. I'm going to move on to the next page. We are on page 95. And on page 95, it asks me to use a straight edge and the grid paper to draw. I know you guys don't have a straight ruler. If you don't have one, you can use a piece of paper. I was using my book marker. So I drew my lines already so you guys can kind of see. It says right here, a trapezoid with exactly 2 right angles. So this is 2 right angles. Right angles are 90 degrees. So, and it's still considered trapezoid because they have 2 parallel sides. Okay, and you have your 2 90 degrees angles, which is your 2 right angles. So I did that. That's all you have to do for problem A. Now for problem B, it says a trapezoid with no right angles. So none of these are right angles. A right angle looks like that, right? And that is not a right angle. So I did what I was asked to do, and it has no right angles. So that is all you need to do for problem B. Now, I'm going to move on to problem number 2. I was going to say C. Kaplan incorrectly sorted some quadrilaterals into trapezoids and non-trapezoids as pictured below. So we have quadrilaterals that have been formed into trapezoids and non-trapezoids. So trapezoids and non-trapezoids. They made a mistake. So circle the shapes that are in the wrong group and tell why they are sorted incorrectly. So I'm looking at the image here and I'm looking for the only thing I should have are trapezoids. I remember trapezoids have parallel sides, right? So right here, I see parallel sides, right? This one also have parallel sides. This one also have parallel sides. This one also has parallel sides. Looking at this one doesn't have any parallel sides. So it does not belong. I'm going to circle that one and write no parallel sides because a trapezoid needs to have parallel sides. Now the non-trapezoids. Looking at that side, non-trapezoids must have at least one pair of parallel sides. So I'm looking to see which one has parallel sides and which one does not. So, okay. I see this one is definitely a non-trapezoid because it's a rectangle. And then this one is also a non-trapezoid. And this one as well. So, these are considered trapezoids because they all have parallel sides. So this one right here has parallel sides. This one has right here has more than one parallel side. It has 2. So these are all trapezoids. All trapezoids because they each have at least one pair of parallel sides. Now, why am I saying that? Earlier on, for the beginning of the paper, the lesson, I said that a trapezoid is a quadrilateral in which at least one pair of opposite sides is parallel or are parallel. So in this case, all of these three would be considered trapezoids, and the one in the middle is not a trapezoid. So it stays where it belongs in that category. So for problem B, explain what tools would be necessary to use to verify the placement of all the trapezoids. So we don't know if they actually are parallel, but the way they look tells us that they are. If you notice, these are both straight edge sides that are the same. So that's how I'm assuming that they are parallel. But to figure that out for real, we would need a tool that actually allows us to find parallel lines. Without a tool, you can't 100% say it's parallel. However, you can assume in this case because of the drawings that they created. Okay, I'm going to turn the page. We are now on page 96. And on page 96, it says use a straight edge to draw an isosceles trapezoid on the grid paper. So I drew my isosceles trapezoid on the grid paper. Now the question states, why is the shape called an isosceles trapezoid? So it is called an isosceles trapezoid because the two slanted sides are the same length. Okay, so if you notice, they have the same length, so they are considered isosceles trapezoids. Okay, and that is all for the lesson today. There are some different shapes here if you want to identify them as, oh, actually, this is for tomorrow's lesson. So this is polygons. So tomorrow we'll learn more about polygons. But if you look at the other pages, they kind of show you examples. This one's a quadrilateral and this one's a trapezoid. Okay, and this is another paper, says the same thing, trapezoid and quadrilateral. Very good, you guys.